All right, today we're going to learn about synthetic division, which is a way to determine if something is a factor of a polynomial. So quickly review, a number is considered a factor of another number if it divides into that number evenly. All right, so there's no remainder. So like 3 is a factor of 24 because 24 divided by 3 is 8 with no remainder. The other factor would be 8. So 3 and 8 are factors of 24. A polynomial is considered a factor of another polynomial if it divides into that polynomial evenly. So no remainder. The problem is we don't know how to divide polynomials yet, so we have to learn how to do this. Okay, one strategy is long division. Just like you guys did in elementary school, okay, we want to do long division. All right, so here's an example worked out, right? 936 divided by 4. Ask yourself, how many times is 4 going to 9? That's 2. You multiply 2 times 4 is 8. Subtract. Get 1, bring down the 3. 4 goes into 13 3 times. 3 times 4 is 12. Subtract. 13 minus 12 is 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. 0 is the remainder. So 4 is a factor of 936, and so is 234. All right, so you guys are going to try this one right here. So pause the video and try it on your own. 3 goes into 16 5 times. 3 times 5 is 15. And we subtract. 16 minus 15 is 1. Bring down the 4. 3 goes into 14 4 times. 4 times 3 is 12. Subtract 2, or subtract 12, get 2, bring down the 1. 21, 3 goes into 21 7 times. 3 times 7 is 21, so the remainder is 0. All right, so 3 is a factor of 1,641, and so is 547. So this is long division of numbers. The same strategy of getting a number up there that goes into it and multiplying it, all right, and subtracting is what we're going to do with polynomials. Okay, so if we want to check if a polynomial is a factor of another polynomial, we must divide the two polynomials. If the remainder is 0, then it is a factor. Okay, look at the next example to learn how to divide polynomials using long division. Okay, you can divide any polynomial using this technique. All right, so we have an example here. All right, and so this example has a number 1 on it and a polynomial one. So we want to divide 2x squared plus 7x plus 7 divided by x plus 2. So x plus 2 is the divisor. Okay, 2x squared plus 7x plus 7 is the dividend. We want to know how many times will x plus 2 go into that. So you just look at the first term, x, and you ask yourself, how many times does that go into the first term here, 2x squared? And that goes into it 2x. That will go on top. Now you multiply 2x times x plus 2, and you get this line, 2x squared plus 4x. Okay, we subtract that. The 2x squareds are going to cancel out. 7x minus 4x is 3x. Bring down the 7, and then repeat. How many times does x go into 3x? 3 times. Multiply 3 times x plus 2. You get 3x plus 6. Subtract, and you get 1. So this has a remainder of 1. All right. Here's another example, maybe a little bit easier to read. Again, so we repeat, okay, what we just did there. This is the dividend is 8x cubed minus 10x squared minus x plus 3. The divisor is x minus 1. So we ask ourselves, how many times does x go into 8x cubed? And that's going to be 8x squared, right? So if you just divide 8x cubed divided by x, what do you get? You get 8x squared. That goes up there. Now you need to multiply 8x squared times x minus 1. And when I do that, I get negative 8x cubed plus, I get 8x cubed plus 8x squared. Now I'm subtracting this. Okay, so you can see in this example, the negative's already been distributed. All right, so these are going to cancel out. Negative 10x squared plus 8x squared is negative 2x squared. And I repeat. So how many times does x go into negative 2x squared? So that's negative 2x. Then I multiply negative 2x by x minus 1. All right, and I would get negative 2x squared plus 2x, but I'm subtracting it, so I changed all those signs. All right, those cancel out. Negative x minus 2x is negative 3x. Okay, x goes into negative 3x, negative 3 times. Multiply that, I get negative 3x plus 3. I change the signs again, and then those are all going to cancel out. So I have a remainder of 0. So in this example, x minus 1 is a factor of this, and the other factor would be 8x squared minus 2x minus 3. If I were to multiply those out together, I would get the dividend again. All right. But the good news is we don't have to worry about long division. Okay, in Algebra 2, we will need to find factors of polynomials, so we need to be able to divide polynomials. We will only be looking for linear factors of polynomials, so we can use a shortcut called synthetic division. All right, so that strategy of long division will always work, okay, even if it's not a linear binomial. But in Algebra 2, we're only going to focus on linear factors. All right, so we are going to learn a much simpler, okay, quicker way called synthetic division, all right, to see if a linear binomial will be a factor of another polynomial. All right, so let's take a look. What is synthetic division? It is a shorthand method of dividing a polynomial by a linear binomial, okay, by using only the coefficients. So we're not going to worry about the variables until the end of the problem. For synthetic division to work, the polynomial must be written in standard form using 0 as the coefficient for any missing term. All right, so if I have a cubic term, a quadratic term, but no linear term, and then a constant term, I have to put a 0 in place. We'll see an example of that. All right, so right now, here's an example of synthetic division. So here's the original problem. 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. To set this up using synthetic division, we only worry about the coefficients. So we write down the coefficients of our dividend: 2, negative 5, negative 1, and 3. So those go right there in a list. Notice, okay, every term is there: cubed, quadratic, linear, constant. So I didn't need to put any zeros in there, right? Then my divisor, okay, it was x plus 3, but I want to know if that what makes that 0, and that's negative 3. That's what I'm going to use as my divisor, is the opposite there, whatever makes that 0. All right, so negative 3 goes there. And we just follow this pattern. All right, we're going to bring down the first one, and then we multiply the divisor, negative 3, by that number, 2, so we get negative 6. That goes up there. We add these together. Negative 5 plus negative 6 is negative 11. And we multiply. Negative 3 times negative 11 is positive 33. We add negative 1 plus 33, we get 32. We multiply. Negative 3 times 32, we get negative 96. We add, we get negative 93. This last number is our remainder. The next number next to it to the left is the constant term, then the linear term, then the quadratic term, and so on. It would keep going. So now this is my answer. I just got to throw all those variables back on there. So if this is the quadratic term, I throw an x squared on it. If it's a linear term, I throw an x on it. Constant term, nothing. And then the remainder, we just write as a fraction over the original divisor of x plus 3. So my final answer here is 2x squared minus 11x plus 32 plus a remainder of negative 93 over x plus 3. So if I asked you, is x plus 3 a factor of 2x squared minus 5x squared minus x plus 3? The answer would be no, because the remainder was not 0. All right, so we want to try this. So we got to set it up. All right, so when I set this up, okay, I write it a little bit different than the last example. I put the divisor in a little box. So my divisor is going to be negative 9. I write my coefficients out: 1, 5, negative 45, negative 81. Those are all my coefficients. I draw a line. I bring down the first one, and now I begin the pattern. Multiply, add, multiply, add, multiply, add. The last number is your remainder. My remainder is 0. Okay, so my factor remaining constant linear quadratic. So my answer was x squared minus 4x minus 9. All right, so if I divided it, that's what I would get. But my question is asking, is x plus 9 a factor? Okay, and the answer is yes, x plus 9 is a factor because we got 0 as a remainder. The other factor would be x squared minus 4x minus 9. All right, another one, let's determine if v minus 4 is a factor. All right, so we got to set this up. 4 in the divisor box. Then we got a 1, we got a 4, we got negative 29, negative 20, 29, and 15. Again, no zeros because I have all the terms, right? I have the 5th degree, 4th, 3rd, 2nd, 1st, and the constant. So I don't have any missing terms. Oops. All right, bring down the first one, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So is v minus 4 a factor? And that answer would be no, okay, because I have a remainder of 3. All right, now my answer, but if I wanted just the quotient, if I asked you to write this, I would throw all the variables back on here. All right, this is my constant, linear, quadratic, cubic, and 4th degree. So it'd be v to the 4th plus 8v cubed plus 3v squared minus 8v minus 3, and then the remainder is 3 over v minus 4. Okay, we're going to learn something about this remainder here in a little bit, but right now we're just focused on, is something a factor? So again, we set everything up, okay, and then we bring down the first one, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add, okay, all the way until we get to the last one, and that's our remainder. Again, if the remainder is 0, we are good. It is a factor. If it's not 0, okay, then it's not a factor. We have to try something else. All right, now we have this example here. All right, so I set it up. I put 6 in my divisor box. Set it up. 1, negative 6, 0, 3, negative 18. Okay, why did I put the 0 right there? Because there's no k squared term. There's no quadratic term. So I need to put a 0. All right, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and I get a remainder of 0. If I throw everything on right now, remember this is the constant, linear, quadratic, cubic. So this would be k to the 3rd plus 3. That would be my quotient. All right, but just answering the question, is k minus 6 a factor? Yes, because it's 0 right here. The other factor would be k cubed plus 3. All right, factors. If the divisor is a factor of the dividend, then the quotient is also a factor. Like in the last example, k cubed plus 3 was a factor. This is important because this means we will be able to write polynomials in factored form once polynomials are in factored form, we can identify the x-intercepts. Okay, special circumstance. Okay, what if the linear binomial we're dividing by has a leading coefficient, such as 9x plus 4 has a leading coefficient of 9. Okay, if that's the case, then you must use -49 as the number to divide by, since it is the value that makes the divisor equal to 0. What makes this divisor equal to 0? It's -4/9. If the remainder is 0, then 9x plus 4 is a factor. Okay, but this is the special circumstance, but the quotient is not the other factor. You must divide that quotient by the leading coefficient to get the other factor. So let's do an example. So here's that same problem. All right, so if I set it up in the divisor box as -4/9, then I have 9, -50, -15, and 4. Bring down the 9, multiply -4/9 times 9 is -4. Add -54. -54 times -4/9 is +24. Add, that's 9. -4/9 times 9 is -4. That is 0. So 9x plus 4 is a factor, all right? But this is not the other factor, all right? I need to divide this by 9. So if I divide all these by 9, I get 1, -6, 1. So my other factor is x squared minus 6x plus 1. All right, so that's one factor. The other factor was 9x plus 4. All right, so in the future, we're going to be asked to solve. So if this is equal to 0, right, we know one answer is -4/9, and then we could use the quadratic formula to find the other one.